Hello, everyone. Welcome back. Today, I'm going to be talking about factoring polynomials. So, let's first talk about how we would factor quadratic polynomials. So, likely we already know the methods for these, but this is just for practice to remind ourselves how we are going to do this. So, we're going to factor by decomposition. So, for this one here, we have 12 and we have 3. For 12, we know that 1 times 12 is 12, and also 2 times 6, and also 3 times 4. And then for 3, it's just 1 times 3, and that's it. So we need to swing these in such a way that we're going to end up with 13x in our middle. So we could do it this way. We could say 3 times 3 and 4 times 1 will get us there. So therefore, the answer here would be 4x plus 3 times 3x plus 1. Let's do one more like this. In this case, we have 3 and negative 8. So let's see, 3 and minus 8. So here we have just 1 times 3. And then over here, we're going to have, let's see, 1 times negative 8, negative 1 times 8, negative 2 times 4, and 2 times negative 4. So let's see, if we do negative 4 times 3, we get negative 12, plus 2 gives us negative 10, so that's going to be our answer. So we're going to end up with 3x minus 2 times x minus 4. Now, I will say if the quadratic factoring part is confusing, please do make sure that you review that because that is material that we taught in grade 10 and 11. I can recommend some resources for that if that's something you're struggling with, but it is very important that gets settled, especially for this unit. We will be coming back to this and using all the factoring techniques we've learned previously in order to solve these kinds of questions. Okay, so this is important. Now, as for the new stuff, the first thing I want to talk about is factor theorem. So factor theorem states that when we have a polynomial f of x, when f of a is equal to 0, then x minus a is a factor of polynomial, because what f of a does basically is it tells us what the remainder would be if we were to divide by x equals a, right? So f of a in general is equal to the remainder when f of x is divided by x minus a, right? When we have f of x divided by x minus a, and we get a remainder 0, that means it is a factor. If the remainder is not 0, then it is not a factor. Now, I will say factor theorem is very useful for determining what is and isn't a factor, so that once we find a factor, we can use our long division method, which we learned last time, in order to solve. However, it's not very useful in terms of actually finding the solutions, right? Because it just tells us whether something is a factor or isn't, so it helps us know what division to do, but it doesn't actually help us find the answer. Really, we still have to, once we figured out what the factor is, we still have to actually do the division to find the answer and find out how to factor it. So example 3 doesn't ask for what is the answer, though. They just ask, is x minus 1 a factor of this polynomial? Well, to do that, we need to figure out what is f of 1, and if f of 1 turns out to be 0, then it is a factor, and if f of 1 turns out to not be 0, then it is not a factor. So let's see. Here we're going to have 1 to the power of 4 minus 7, 1 cubed, plus 2 times 1 squared, plus 9 times 1, which is 1 minus 7 plus 2 plus 9, which is, well, it's not going to be 0. I already saw that. Question is, what is it? It's going to be 12 minus 7, which is 5. So 5. And 5 does not equal to 0. And therefore, x minus 1 is not a factor because the remainder is not 0. right? The remainder is 5. Although the important thing isn't that the remainder is 5, the important thing is the remainder isn't 0, because any non-zero remainder means it's not a factor. Okay. Now here it says state the remainder when 4x minus 10 is divided into this polynomial. Well, we need to know when is 4x minus 10 equal to 0. That means 4x would be equal to 10, and that means x would be equal to 2.5. So therefore, we need to find what? We need to find out f of 2.5, and by finding f of 2.5, we can find out what is the remainder. So let's see, we have 2 times 2.5 cubed minus 5 times 2.5 squared minus 2 times 2.5 plus 5. So over here, these are going to cancel out because this is minus 5 plus 5. What about over here, though? Let's see. Here we're going to have 31.25 minus 31.25. Oh, so those cancel too. So we actually do get 0 here. So therefore, the remainder is 0. And if they had asked us, oh, is this a factor or not a factor, we would say that yes, it is a factor, right? Because remainder was 0. Good. Okay, let's move on to example 5 and 6. Okay, so example 5 says factor x cubed minus 5x squared minus 2x plus 24 using the factor theorem. So I do want to also just reiterate here that we can't do this just using the factor theorem, right? The factor theorem only tells us which values are factors or not factors, right? But we can use the factor theorem to help us to know what to divide and how to factor. So I'm going to take a look at this and see what value might be right. Okay, let's just kind of picture it. If I put in 1 or negative 1, that's not going to work. What about 2? Would 2 work? Let's see. F of 2, that would be 2 cubed minus 5 times 2 squared minus 2 times 2 plus 24, which is equal to 8 minus 20 minus 4 plus 24, which is equal to 8. So no. So that's not right. So basically, we saved ourselves from doing an entire long division with that quick piece of math to just show that no, x minus 2 is not a factor. Now, what about f of minus 2, right? Is x plus 2 a factor? Now we have negative 2 cubed minus 5 negative 2 squared minus 2 times minus 2 plus 24. You do not. Plus 4 plus 24. Oh, and this will be 0. So therefore, we do have a factor. So therefore, x plus 2 is a factor. So now that we know it's a factor, we can use our long division method to solve this. Okay, so going back to our long division method, we have x plus 2, and then here we have x cubed minus 5x squared minus 2x plus 24. So how many times does x go into x cubed? Well, x squared times. What's x times x squared? It's x cubed. And what's 2 times x squared? It's 2x squared. And then we subtract. And then we end up with negative 7x squared, and then we bring down the negative 2x. Now, how many times does x go into negative 7x squared? Negative 7x times. So then we have negative 7x squared minus 14x, and then we subtract, and then we end up with 12x. And then how many times does x go into 12x? Well, 12 times, so plus 12. And then we're going to get 12x. We bring down our 24. 2 times 12 is also 24, so we get 0. Now, I do want to point out here that let's say we hadn't gotten 0. That would mean in this situation that we had done something wrong. Because we proved based on our factor theorem or our remainder theorem that we should get a remainder of 0 when we do this division. right? And so if when we do the division we don't get a remainder of 0, that means either we did the long division incorrectly, or we plugged it in, or we did factor theorem correctly, plugged in something and made some calculation error in our original calculation. It's one of those things. And so it needs to always be consistent, right? Our long division be having a remainder of 0 should always line up with our factor theorem or our remainder theorem telling us that the remainder is 0. So definitely keep that in mind. Okay, so that said, we know that x cubed minus 5x squared minus 2x plus 24 is equal to x plus 2 times x squared minus 7x plus 12. And then can we factor this further? So it's possible we can. So let's see, let's go back to just our quadratic method. So what are two things that multiply out to 12 and add up to negative 7? Well, I guess negative 3 and negative 4 is the first thing I can think of, so that is going to work. X minus 3, x minus 4, and therefore this is the factored form. So this would be our final answer of the factored form, because that's what the question asked for. They asked for the factored, spelled correctly, form. There we go. And I do want to point out, even though it did say use the factor theorem, we didn't just use the factor theorem. We used the factor theorem to get the first factor, and then we used other methods to complete it. So just because it says to use the factor theorem doesn't mean that that's the only thing we can use, but it does mean, if it says it in the question, that we do need to use that method at least once if it is asking for it. Okay, let's move on to this one, example 6. It says to factor this polynomial using factor theorem. So before we do that, one thing that I always say in the grade 10 and 11 courses when it comes to factoring, and that I will say again here, is always common factor first. If you can common factor, always do. Unless unless the goal is not to fully factor something, like if the goal is to complete the square, your goal is to do something different, then you don't have to always common factor. But if your goal is to factor something, always common factor first. Okay, and here our goal is to factor. And so even though it says to use the factor theorem, we will, but we should not forget about common factoring first. So what can we common factor? Well, it looks like the biggest thing we can common factor out of here is a 2x. So let's do that. 2x times, let's see, 2x cubed plus 3x squared minus 3x minus 2. Okay, and let's give the function that's inside these brackets a name. Let's give it a name of f of x. Or no, maybe g of x. Let's say g of x. Let g of x equal to, actually let's move this downwards, because we're going to want more space for the factoring later, equal to just this part here. Okay, now based on this, what do we think might give us remainder of 0? Well, I have a hunch that maybe 1 will, because I'm guessing we'll get 2 plus 3 minus 2, and that gets us 0, if we just plug in 1 for x. So I'm going to do that. Let's just plug in 1 for x. So g of 1 is equal to 2 times 1 cubed minus 3 times 1 squared minus 3 times 1. Oh no, sorry, this is plus. This is plus. I was going to say, wait, did I do that incorrectly? But no, it was supposed to be plus minus 2. So that's going to be 2 plus 3 minus 3 minus 2, which is 0. Awesome. So what does that mean? Therefore, x minus 1 is a factor. Okay, that's our conclusion from that based on that factor theorem we learned earlier. So now what do we do next? Well, we're going to actually do the long division here. X minus 1, and then 2x cubed plus 3x squared minus 3x minus 2. And again, because we concluded from the factor theorem that x minus 1 is a factor, we should get remainder 0. And if we don't, we've made a mistake, and we should go back and fix that mistake. unless you're writing a test, then decide if you have time on the test or not to do that, or if you'd be better off doing other stuff. But do just know you got the wrong answer if it does not line up with what you found in your factor theorem. Okay, let's move forward. So how many times does x go into 2x cubed? Well, 2x squared times. X times 2x squared is 2x cubed. Negative 1 times 2x squared is negative 2x squared. And then we're going to subtract. So then we have 5x squared over here because we have 2x cubed minus 2x cubed, which is 0. And we have 3x squared minus negative 2x squared, which is actually 3x squared plus 2x squared, which gives us 5x squared. And then we bring down the minus 3x. Now, how many times does x go into 5x squared? Well, 5x times. And negative 1 times 5x is negative 5x, and then we subtract. So 5x squared minus 5x squared is 0. Negative 3x minus negative 5x would be negative 3x plus 5x, which is 2x. And then we're going to bring down the negative 2. Now, how many times does x go into 2x? Well, 2 times, so we'll just do plus 2 there. 2 times x is 2x, and then negative 1 times 2 is negative 2. And all of this, of course, just gives us 0, remainder 0, which is good because that's consistent with what we thought before. So therefore, we can do the next step of the factoring and say this is the same as x minus 1, 2x squared plus 5x plus 2. And now we're just left with a quadratic, so we need to decide, can we factor this quadratic down further or can we not? And in this case, yes, we can, I believe. If we do 2 and 2, we can multiply the 2's together and the 1's together to get and add those up. So 2 times 2 plus 1 times 1 gives us 5, which is our middle term. And we can end up realizing that the answer here will be 2x minus 1 and x plus 2. And there we have it. And again, if you're not as familiar with the with this method of doing it, make sure that you get there. Or sorry, this should be plus. My apologies. I put it as minus, but it should be plus because if we factor it out, yeah, it should be plus. My apologies, not minus. But yeah, so therefore, that is going to be our final answer. And there we have it. Now, that said, I do want to mention some prerequisite skills you'll need a lot for this course. So do make sure you understand like the long division and the factor theorem and the new stuff, but also it's just as crucial to make sure you also understand like factoring quadratics and all those previous factoring methods we learned, because those come up repeatedly in this course as well. So do make sure that you go review those if you need to do so as well. But yeah, good work, everyone. And that's it for today. Bye, everyone.